Thank you very much. Hello everyone. I am Hakan Savaşan of Profen, and I am responsible for the R&D and innovation portfolio of technology part. First, let me briefly introduce Profen. We are a group of companies, and the main axis of our business is Satcom Technologies. We are in the industry for the last 25 years, and we serve our customers as the main systems integrator, R&D-based ground equipment manufacturer, and teleport operator. We are a government-approved R&D center whose activities are legally audited by government every year. You can see the other numbers related to our company on the slide, but let me go over it. The 20% of our annual budget is R&D and innovation expenditures, and a significant portion of this is being used to develop LEO and MEO technologies, which we see a great feature and commercial opportunity. Just to answer the Barry's question, I'm a hybrid guy, so I believe GEO, MEO, and LEO, they will all continue it together. We can list Profen's MEO and LEO products and services in three main tiers: connection, infrastructure, and services. But first, I would like to go over the verticals we are targeting right now. We consider that we can easily reach our customers, especially in transportation, enterprise, and agriculture, as well as defense and government. In fact, a significant portion of our existing large accounts are already in these sectors. On the satellite access tier, we are concentrating our R&D activities to diversify our XY pedestal solutions. We will provide different XY pedestal solutions for reflectors between 2 and 7 meters, suitable for S to Ka band to our customers. We all know the importance of cloud computing in MEO and LEO technologies. We are developing Profen cloud infrastructure, which is optimized for Satcom applications, and it will soon be ready to be deployed in the field. In the medium term, we want to add virtual network functions to our cloud infrastructure as well to implement a virtual ground station. We want to provide Profen Satcom cloud services to our customers with built-in MEO and LEO applications using our satellite access and cloud computing infrastructure solutions. Our R&D activities continue intensively to implement highly secure managed services, which will provide real-time monitoring, control, and orchestration of the satellite ground segment with predictive maintenance applications supported by machine learning and deep learning. What you see on this slide is our first XY pedestal solution for LEO satellite tracking delivered to our customer. This system is a complete ground station solution designed entirely by Profen within the scope of the Turkish National Ground Station Development Program. All active and passive RF chain, antenna motion system, and control software of the antenna were designed and developed by Profen. The 7.3 meter reflector of the antenna operating in the dual band is made of carbon fiber material. Ground station can perform monopulse and program track both in X and S bands. The XY pedestal solution we developed here can be used with different reflector diameters between 6 to 8 meters. We started another R&D project in order to develop another XY pedestal with higher positioning accuracy, which can be used in higher frequencies with mid-sized reflectors to meet the ground station requirements of the MEO and LEO satellite constellations, which are very popular today. This government-funded project was successfully completed at the end of 2020. Now we are optimizing this pedestal for cost and manufacturability. The pedestal can be used with dishes between 2 to 4 meters, suitable for S2 Ka bands. The most important problem we encountered in this project was meeting the high positioning accuracy required in very high frequency bands. In late 2020, we started another internal product development project to develop an advanced, mid-sized, cost-effective MEO and LEO satellite tracking antenna. You see our Ka band XY pedestal ground station with 3.5 meter carbon fiber reflector in the picture. We are in the critical design phase. Hopefully, the antenna will be ready to go to the market by the end of 2021. I think Profen Cloud architecture is the most important R&D initiative we are carrying out in Profen right now. It will be used as the infrastructure of our cloud-based LEO MEO services in the near future. We are developing it in collaboration with Turkey's most competent universities and scientific institutions in cloud computing and big data area. Our goal is to create an open source-based, scalable, very low latency cloud computing infrastructure fully customized for Satcom applications. Profen Cloud will have built-in ground network monitoring, control, and orchestration services, as well as machine learning, deep learning services for anomaly detection, predictive maintenance, and it will also support machine learning tasks which require classification and regression. Also, we will provide edge computing capabilities to meet the demands of time-sensitive applications. This cloud architecture can provide infrastructure as a service, platform as a service, and software as a service types of services. In order to make this architecture cyber resilient, we have started to work on artificial intelligence-based cyber security solutions for Satcom ground segment. For the Profen takeaways, due to mega constellations for broadband internet connection, we think MEO and LEO will be the main driving force of Satcom industry in the next 5 years. Of course, GEO will be affected from these developments since there is a real demand to reduce cost per bit. For example, the GEO very high throughput satellites will be a viable solution in the GEO side. Scalability, agility, and reconfigurability are key features of LEO and MEO technologies, which is already being incorporated in space segment. These features should also be added to the ground segment, which will pave the way for the virtual ground station. We think up to 5 years, fully virtualized ground stations will be the main element of the ground segment itself. On the other side, satellite constellations will need many ground stations on the connection tier. Despite the challenges in its design, XY pedestal appears to be the most cost-effective solution for MEO and LEO tracking due to its ease of production, maintenance, and repair. Cloud computing, big data analytics, and artificial intelligence are at the center of all LEO and MEO innovations. For cyber threats, the only way to reach a satellite constellation is through the ground network. So in this software-intensive ground segment era, spatial cyber security solutions developed for satellite communication systems are of great importance. Therefore, advanced artificial intelligence-based cyber security products promise great economic returns both for end users and solution providers. That concludes my presentation. Thanks for joining the event and enjoy your time.